computer. Perfect. Okay. All right, everyone. Thank you for coming. Hopefully, I have a few more people trickle in. So our topic that we're covering today is state management. And while I am doing that, let me go ahead and share my screen. I actually did some diagramming for everyone. Ooh, ah. Okay, so just to kind of set expectations for the meeting, state management I regard as probably one of the most complicated tasks in kind of the front end world. So today is just going to, like, I'm barely going to scratch the surface today. So my goal today is to just expose you to some of the conceptual and architectural patterns that we like to use and why we like to use them. I want to kind of go over some of the pros and cons of NGRX and Akita. I want to do a brief high-level overview of Akita and some of the building blocks. I mean, a lot of people have been using it for a while already, and a lot of people have not. And then I kind of want to go into sort of hard learnings and show off some of the different approaches to state management in kind of various applications. So, all right, so to kind of get started here, so if you can see my screen here, this is what I would regard as a standard Angular application, where if you notice that we have our service, where we have shared business logic, we have our routes, which we intend to be smart, and we have our dumb components, which are downstream of that. Now, if you notice with the arrows, data is flowing two ways in this application. And this is actually kind of, I mean, this is kind of normal, but it's also problematic. One of the problems is we don't know who has the source of truth for state. So if we use an example, let's say this route has a sidebar open, or one of these lower order components has a sidebar open. Where do we store that? Where do we store that property? Do we store it on the route? Do we store it on the component? Do we store it on a lower order component? It's kind of hard to do that. The other problem is we don't know who owns the data. So in the case of data in the service, what happens if this route modifies data supplied by the service that this route needs? And so you can run into a lot of really strange issues when you have two-way binding. So which brings us to the the state management pattern that we're using that everyone's kind of standard on. It's called Flux. And let me just give you a little brief background on that. So Flux was pioneered by Facebook many moons ago because Facebook is a ginormous application, hugely complex, and managing state is a huge problem. And it arose out of the notifications bar. So I've been on Facebook for a long time, so I don't know how it still works. But when people comment or message, there's a little red circle with a number of information on there. And Facebook was having a hard time keeping that in sync because so many things impact that. You'd have all kinds of lower order components making changes. You have to detect, when people are doing posts. And so it was always out of sync. And so they pioneered the Flux pattern. And I want to emphasize it's a pattern. The pattern itself, it can be implemented many different ways. And so what I want to do is I want to cover the sort of the architectural pattern and sort of the pros and cons and kind of the gotchas and all that kind of stuff. And then I want to cover specific implementations of the pattern, specifically NGRX, Akita, and my own homebrew solution, which is useful for kind of different use cases. So before I kind of dive into that, feel free to interrupt me at any time. Otherwise, I'll forget to pause and ask for questions and all that kind of stuff.
Moo.
What's up? Welcome. Okay, so let me just talk through what are the components of the Flux pattern and and then I'll dive into how they're using. So the first one is called unidirectional data flow, which means data only ever flows one way through the app. So in this particular case, you can always see that my data always flows down and actions flow up. So this means that lower order components never modify data. They just pass up information on how to modify that data, and then your store up here makes the change. And this is a very, very common pattern. So this fixes all kinds of problems with side effects and race conditions. Data flows one way through the app. The next part of Flux is what's called a POJO, or plain old JavaScript object. And what a plain old JavaScript object is your single source of truth for state in your component, your app, whatever. It's going to be on a case-by-case basis. And again, a lot of us are already used to this with Akita or NGRX, where we have one object and it contains all the properties, entities, objects, or whatever for a particular piece of state. And this JavaScript is the source of truth, and everybody reads from that. Another piece of Flux is immutability. This should be pretty standard for every. So basically, we don't mutate. We always return new memory references every time we modify. So this prevents mutation-based side effects, which if you've ever had to troubleshoot a mutation-based side effects, you'll understand why they're so nasty and hard to trace and cause a lot of problems. So immutability sort of fixes that, and also prevents a lot of bad practices in terms of like modifying downstream stuff, and then highly performant in terms of change detection. And then something that's not part of the Flux pattern, but which everyone's built on top of, is the observable data store concept, where we take our JavaScript object, which is a single source of truth, and we wrap that in observables, so that way downstream subscribers all have basically talk to the same source of truth, but then they all kind of get the update. And that's kind of the Flux pattern. Any questions or comments on that before I move on to the next topic? Cool. Okay. So now that we've talked about the Flux pattern, there's a couple different ways to implement it. And on the React side of things, this is Redux. And on the Angular side of things, we have NGRX and Akita. And they both kind of take different approaches to how they do it. And they're both pros and cons. So for the most part, we standardize on using Akita. And Akita has a lot of benefits. It's easy to use, it's easy to scale, it's easy to understand for new engineers. But as I've recently discovered, Akita has some limitations like that make it not the best choice for everything. Kind of on a personal note, state management is probably one of my personal hobbies, probably because it's such a hard problem. Like there's no one size fits all. And every time you think you've got a good pattern, an architectural pattern that's going to fit your stuff, you get exposed to a new concept that sort of breaks that mold. Okay, so the most common, I want to call out something else that's really interesting here. So if you notice with our component structure here, data is linear going up and down my tree, up and down the sort of the component tree, right? So it goes, this lower order components pass up, 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 up. One of the problems with this approach is it's a lot of data passing. If you've ever worked with a fairly deep component train, having to emit up 3 or 4 different layers is hugely problematic, and just a lot of code, and it feels janky and whatever. Something that's interesting with the Flux pattern is we can still follow the concept of unidirectional data flow, because you notice my lower order component down here can actually communicate straight to the store. Now, should I do this all the time? No. But there are lots of use cases where it makes sense to not pass data up the component chain and to communicate directly with the store, as long as you're following unidirectional data flow. So in this case, this component is not going to modify whatever it's working on. It'll pass that action up to the store. The store will modify it and then pass all that data back down, and this will re-render. So this is kind of a this is a very, very useful tool in your toolbox, but it's also on a case-by-case basis. Something else I want to call out here is shared business logic versus state. So one of the problems of this kind of pattern is, where does state live? And it's actually kind of a hard question. So our service has our shared business logic, and sometimes it has state. And sometimes state is in our route, and sometimes state's in our component. What Flux pattern does, and it doesn't sort of break this rule, but it gives you more flexibility, is it gives you a single source of truth for state. So if I have sidebar open here, here, or here, I don't know. And let me sort of go into why would we want to use a store. So here's some kind of topics for that. So when to use a store. So when I have multiple areas of application that need a particular piece of data. So let's just use my example. Maybe I have some tabs on a page. In all likelihood, those tabs don't need to be used external to the component that has those tabs. There's no reason to no reason to pass that data around, no reason to have a property. If you put every single property in your store, obviously your store is going to be huge and unmanageable, and you don't need to it. So this is the first time. So a common example is API data. So if I get back a list of data from the API, odds are multiple areas of the application are going to need it, so they're going to need to subscribe to that data. So that's a good example to use a store. Another one is persistence. So a common request from business owners is that when I refresh my app, I want it to go right back to where it was. So this, and this is very hard to do on a component level, but if you have a store that's a single source of truth, you can take that object, write it to local storage, and when your app loads, pull that out of local storage, put it back in, and now you will arrive right back at where you were. And so this makes it very, very simple for you to kind of persistence. The other thing is it's not just local storage, it's a remote, it's remote too. So for instance, on some of the applications we build called the wizard, where you can be like on step 1, 2, 3, 4, 5, and you've selected different things along the way. If you were keeping all of that in a store, you can literally pass that entire JavaScript object to a remote API. And then when you get it back, rehydrate your store and everything's exactly where you are. Third point is when you're managing complex internal state. So we've all built components that are a lot, I mean, most of our components that we build are presentational, they're dumb, they have no internal state, they're derived entirely by their inputs. But we have a lot of components that are huge. So if I pull over, let me go ahead and just pull this over here. I have my map component here. Load, dang it. This is a huge component. There's a lot of complex things going on. We have to manage data sources. We have to manage layers. We have to manage boundaries and polygons and all that kind of stuff. Where does all that data live? Well, it makes sense to have a dedicated store just for the map to sort of manage the map state. And then the last kind of use cases, I mean, there's many more than this, of course, but these are just one that came to mind, is application snapshot. So this is a very, I like to call this a save game mentality. So one of the questions I get asked a lot is what goes in the store and what does not go in the store. And so if you think like a save game from a video game, if like I click load and I put everything in that object, your application should be in an exact state of where the user left off. And so if you need something to get back to the precise layout and information and all that kind of stuff, a store is an ideal way to go. So a couple things when building your stores, just good engineering best practices. So single responsibility principle. So we want to have one source of truth for a particular area of the app. So in the case of my map, I have one store that deals with all things map and doesn't deal with anything outside the map. The other reason you use store is encapsulation. There's a lot of overlap between these two, where we want all the business logic for one particular use case in one location. So it makes it easier to manage all your effects and all that kind of stuff. Another example is like the grid. Most of you have probably seen that at one point or another. The grid is enormous. There's a lot of complex state. There's columns, there's rows, there's all the custom cell templates, there's what happens when you click on things. And it's a lot simpler when all of those actions are in a single place instead of spread out. We'll go back to this example here, spread out over a large component chain. So for instance, the grid is composed of rows, which is composed of, it has a table, which is composed of rows, which is composed of cells, which is composed of cell templates. And so if each one of those guys is sort of managing its own complete internal state, it's very, very hard to figure out, what does what when. Okay, any questions or comments on that? I'm gonna pause because my mouth is dry. Cool, makes total sense. No questions. Cool. Okay, so next thing I want to go into is I want to kind of compare NGRX versus Akita, some of the pros and cons, and then what I want to do is go into just some Akita overview. So I've had a lot of questions for that. I mean, most of you have been playing with it for one, I've probably been using it at some point, but I can kind of cover that. So NGRX versus Akita. Now keep in mind, both of these are different approaches to sort of the Flux pattern for state management. So what are some things that NGRX does well? Communications between stores. So something NGRX has, it has what's called the dispatcher, and the dispatcher is global. So basically this means that all stores get all actions and can communicate with all other stores. It's sort of built in. This is really nice when you need that. Akita doesn't have anything like this. The other advantage of NGRX is it's very easy to track the flow of store changes. So because everything flows through your dispatcher and it has an action, you can basically console it out and see the entire flow of everything's changing. And it makes it really easy, especially when you have your complex app with a lot of side effects. It makes it really easy to figure out, okay, what went, oh, this fired before this, that's what's going on. And then in similar vein, intentional side effects. And I'll show you some examples of these in my current application, where I click a button and then it fires off an API call. And depending on the API call, it may do one or two different things that may do their own thing. So you have this chain of events that happen. NGRX makes it very simple to do that. Akita, not so much. Now, what are some of the disadvantages of NGRX? Ridiculous amount of boilerplate. So like just to set up a simple store, you need your reducer, you need to declare your store to the dispatcher, you need actions, but actions aren't type safe. So you have to create your type safe action creators. Oh, we're working with entities. We got to wire up our entities now. Okay, now I need to dispatch side effects. So next thing you know, in order to just set a simple key value pair on your store, you've got 100 lines of code. And it gets really bad once you start working with entities or API calls, because then you start building all these ginormous stores that are essentially just copies of each other. Like we all know what to do with the get request. Get request, load the store. So why do I need to keep doing the same thing over and over and over? Hard to set up and extend. So there's a lot of moving pieces in NGRX store. Actions, reducers, side effects, all that kind of stuff. And you kind of need the full circuit in order to even make the simplest of change. It's hard for new engineers to grasp. One of the challenges with NGRX is because you use a dispatcher, there's no way to trace the flow of logic through your application. So in a normal application where you're using services, passing calls, you can just essentially hit F12 and sort of trace all the business logic. With NGRX, you're essentially blind firing changes to your store, and it's up to stores to subscribe and kind of operate them. So it's really hard to grasp for a lot of newer engineers. And last point, just roll your own, seriously. So I'll show you an example of a store that uses NGRX patterns in terms of reducers and actions. And it's like 10 lines of code. Like it's very, very simple. We don't actually need all the overhead of NGRX to get all the benefits. So and then now we're coming down here to trade-offs. So we switched to Akita about a year and a half ago. And since we haven't looked back, Akita makes things very, very simple. But there are some times when that doesn't work out. In fact, let me actually go over Akita's pros and cons first before I go off the trade-off kind of between the two. So one, Akita's advantage is very easy to set up, extend out of the box. So for instance, with NGRX, if you want to work with entities, you've got to install their entity package, you've got to set and then you got to wire the whole darn thing set up yourself. With Akita, you get an entity store out of the box, and it works exactly the way you would want it to work out of the box. And it's 5-10 minutes to wire up a store, and you just install it and set it up, add a model, piece of cake. Akita works great for most use cases. So most of the time, the apps we're building, we're not dealing with a lot of side effects. We're dealing with one-to-one key value pair changes. So for instance, like if my sidebar is open, true or false, like it's just a sidebar open, true or false. I'm just setting single properties on the store. They're not dispatching other actions. And so for almost all the use cases that I've built, Akita works great. And because Akita is easy to set up, we don't have all the overkill and overhead of NGRX. And last point, which I said was a disadvantage of NGRX, it's really easy to trace the flow of logic. So because Akita has a lot more encapsulation around like services and stores and stuff, just all your business logic's in one place, and you don't have to go digging through your actions or your reducer or your dispatch actions to sort of figure out where stuff's happening. It's all there. It's all very simple to use. Okay, so what are some disadvantages of Akita? And just to stress, like, I'm not advocating one or the other. These are just, stuff to think about as you're conceptualizing state management in your application. Akita does not handle communication between stores well. 99% of the time, this is not a problem. But when it is a problem, it's kind of a big problem. For the most part, if I have a UI store, that UI manages a single UI, and it doesn't need to fire off API calls. It doesn't need to make changes to user subscription services or anything. It's a straight one-to-one. And this works great. However, when I need to start having, in the case of my Atom project, I had the map store has to make changes to the, let me actually pull it up here so you can kind of see it. So one of the challenges is I have two stores that sort of power this guy. There's one, which is the state of the map, which is essentially just the UI store. The UI store manages the state. Now, how does that actually look like? Is the boundary button pack? What are the bounds of the map? And then I have a domain store, which holds all the API data from the two. In normal apps, there's not a lot of communication between the two, but in this app, there's an enormous. So if I click the remove boundary button here, I've got to fire off an API call. New data has to come back based on the information that's refreshing. I got to fire off different calls. I should have restarted my app before this. And then the domain store fires some things, and that needs to update map state. And because there's no dispatcher, it's hugely problematic. Like I'll show you some patterns to get around it, but like it's definitely a problem. Cons, okay, easy for bad practices to sneak in. And I will show you with my own code, stuff I learned the hard way and just haven't had time to, we're not going to be able to fix on this project. So the advantage to reducer is it forces you to make all your state changes in a pure function. So you can't do naughty things like introduce side effects or make API calls. And I discovered a lot of this the hard way with Akita because you don't have a single unified reducer. It's easy to do lots of naughty things that you should not do. Handling of intentional side effects is problematic. So in the case that I just exampled with my map, where I clicked the remove boundary button, it doesn't just do one thing. So the remove boundary button removes the boundary, it updates the map. The map fires updates with zooms and bounds change. The zooms and bound change fire API calls. The API calls back, and based on the data that comes back, I make a bunch of other changes. So you have this huge web and flow of logic. NGRX makes that very simple with the use of side effects. Akita, I'll show you some patterns. Not so good. Okay, so before I move on, any questions or comments on this kind of frame? Cool, makes total sense. Okay, so a couple other things I want to call out. Stores, how to use them, where to use them. Let me go ahead and make my screen a little larger here. So let me go ahead and show you the current project, just give you an idea for what we're dealing with here. So if you look on my left screen here, so this is the Atom project that I've been working on the last year of my life practically. Let me show you a couple things. These are just sort of tools in your toolbox. So the thing with state management, there is no one size fits all. There is no like it's going to work for everything. So let me give you a couple of thoughts as you guys are thinking about state management. So one is where to put your store. So we have a couple of options. We have component level stores, we have route level stores, and we have global stores. So if you're looking right here, we're seeing global stores. So I have my domain store, which manages all my API stuff, my map store, my map state, which is a little bit of a gray area because the map only exists in one place, but there's so much data from the map that feeds into it that it makes sense to be a global store, settings, subscriptions, etc. And then I have a global UI store. Okay, this is great. These are global. That means lots of routes need these, lots of pieces, lots of places use these. It makes sense to have these on a global level. Another place to put a store is in your route. So following our standard best practice. So here's my homes route. And if we notice, I have a shared state, and I think the domain store is empty, yes, but I have a route level state service. So again, this comes back to our single responsibility principle. And this is where it can get a little crazy. So the homes route actually has a lot of its own internal state. Let me just kind of wait for it to load here and kind of talk through it. So there's a lot of state that goes into this sidebar here. What properties are showing, the sort, like all this data on here. I have the ability to like zoom in and out. And I apologize, it's running really slow here. So basically there's a lot going on inside here that has nothing to do with the map and has nothing to do with the rest of the application. So this is one of those examples where when you're working on it, you think, okay, hey, where do I put the information about whether that sidebar should be out or not? And follow our standard practices. Well, are other areas of the application going to need it? No. Is it specific to a single component? No. So in that case, it makes sense to put that piece of state in a route level store. Now, another example is component level stores. So while we strive to make most of our components dumb, some of our components are pretty big. So let's go ahead and look at my Azure Maps components. So let me pull this guy back over. Where did I put it? Okay. Okay. So there's actually two things that are going on here. So one, this is an implementation of Azure Maps. And there's actually two separate stores that power this. And it may seem confusing for a minute, but let me sort of walk through it. So one is the Azure Maps store. And then that's just concerned with how Azure Maps works. And it has no business logic specific to the Realty Track implementation. So as far as Azure Maps concerned, all it cares about is their data sources, layers, polygons, adding, removing them, markers, all that kind of stuff. So basically all its inputs have no Realty Track business logic. It's just all the basic mechanics of mapping. And then, so that's basically here. And then sitting on top of that is the store for Realty Track maps that contains all of the business logic that's specific to Realty Track. And so what we've got is now granted, like this is a smaller store and this is a much bigger store, and this store feeds directly to the lower store. But the advantage of that is now I have an Azure Maps component that can be reused by itself. So that's the reason why I didn't combine it. So let's say the client comes to me and says, Gerald, we're going to create a new page with a new map. And if you have good separation of concerns, I can take this map component, drop it in another location, and then build a new store, API call, or whatever. And I've kept my separation of concerns pretty well. So to that end, let me actually show you a component level store. So actually, before I dive into that, let me go into sort of Akita store. So let me go ahead and pause. Any questions or comments on sort of stores, state, kind of how to organize things? Cool. Okay, so let me go into Akita basics, and then we'll kind of show you how things break down. I want to show you custom examples from there. All right, so Akita, let's see, all right. Let me pull up my map here. Okay, so I don't want to spend a ton of time on Akita because, I mean, the docs are available, but I just wanted to, I'll do a high level overview, kind of show you guys where you kind of find things, and then we can do follow-up sessions later. So here's the diagram for Akita. You notice it follows a unidirectional data flow. So the component makes requests to a service, which gets data from the backend, which updates the store. Data from the store is extracted out via the query and updated from the component. So again, here's like a slightly different diagram, but it kind of shows you the Flux pattern. So what are all the building blocks of like an Akita store? So first thing to keep in mind is you actually have two different types of stores, and they matter. One is called a UI store, and the other is called an entity store. The UI store is concerned with all the presentational level stuff of your application. And this is what you would typically expect. Is your sidebar open, yes or no? You know, are you on tap 3 or 4? All that kind of fun stuff. It's basically presentational level logic. Entity stores essentially are ideal for working with API responses. So what's an entity? An entity is really just a JavaScript object that you get typically from the back end. And so what an entity store does is take that and convert that into a hash map. So it makes it essentially turns into like a local database that you can query against, extract data out. And everything else is kind of the same between those stores. So so your main building blocks for an Akita store is one, you have what's called the store. And what the store is it takes an interface of a model of what your shape is going to look like. It takes an object of what your initial starting state. And then here is just your decorator for sort of instantiating the thing. So that's the store. And the store is where you're going to be doing most of your operations. So the deal with the store is where you put data in and modify data inside the store. The next piece of it is the query. Now the query is the other half to the store, where its job is to pull data out. So that's where your select statement is. So basically all it is looks exactly like this. And then you can make queries against, you can pull data out of the store using the query, and then it's off to the races because these are all observables. And that's kind of Akita in a nutshell. Now, the difference being is that with entity management, instead of a store looking fairly flat like this, the entity store looks a little different. Here is what the entity store looks like. If you notice, all of your data is predefined. So what's an entity? Again, entity is just a JavaScript job. So when you load the entity store with the data, it's going to map it down to a hash map, put IDs, and then give you some additional metadata properties. So again, think of this like a local database. So once your data is in here, then we can use queries to actually work exactly like a database query where you can extract slices of data out of the store. 99% of the time, you're just doing a for all loop, or for each loop, and you want everything. But there is a possibility, but if you do need specific slices, it's possible. Full disclosure, I'm kind of lazy about using query. Like it's really easy to just use like a RxJS pipe or map or filter or whatever to kind of get the data in the format you need. But there's a lot of advanced usage on entity stores. Okay, any questions or comments on just high level Akita state or store management stuff? Cool. Okay, so let me go into some of the deltas that we do things a little differently. So if I look at my code here, something we do a little different is we put all our stores in one file. So with Akita, you get like 4 or 5 files. The store has its own file. The the query has its own file, the model has its own file, the service has its own file. And we're like, it's kind of redundant because then you have some duplication of data. Like you need the store name here, but then you have to insert it into the query over here. So something that we've done is we actually put everything in the same file. So if you notice, I'm in map state.service here. Here's my store. Here's my query. And then it's just one file. And this is just for convenience. So if you like different files, that's fine, not a big deal. But we do this for convenience. Okay, so that is that. Let me check my agenda here. Doing good on time. Okay, route. Okay, so go over a couple of gotchas. Where to store state. So another thing to think about is we also use route parameters. So if we go back to my example here, if you look at my URL here, I actually have a list of query parameters that are used to sort of power the store. And so the big difference is, do I put data in the store for managing state, or do I put it in the URL? And the answer to that question is if you need that URL to be routable or not. So in this case, we need the filters that describe the map to be routable. So we put those in the URL, not the store. So when downstream items need those, we'll use something like a combine latest, and pull data from the store and then pull data from the route URL and then sort of combine them all to kind of extract whatever pieces of state. Okay, so Akita, NGRX, click my finger. Okay, so let me show you an example of like a NGRX without the NGRX. So I briefly showed you guys the maps. Let me show you what a simple store looks like that uses the reducer pattern. Let me actually show you. I also want to show you a few things not to do. So on this project, one of the challenges was that we got our requirements piecemeal over the course of 6 months. So normally you try to get most of those up front. And this is why I've run into a lot of Akita limitations on this project, because stuff I knew 6 months ago, if I would have known what I know now, I would have made different design decisions. And the problem was it's sort of, Chinese water torture, where you slowly get more requirements, and then by the time you're so invested in a particular solution, it's too costly to change. And so one of the problems with Akita is you have multiple ways to modify state. So let me just show you an example of what that looks like. I'll do a real simple one here. Where's a nice simple one here? Perfect, right here. So here's an example of how to modify the store. You have a function in your service that takes a value, and you call this.store.update, and it fires it and all the observable fires. But if you notice right above it, I have another function above it that does something different. Okay, that's not too bad, right? These are just one-to-one. Well, now let's look at something really big. So here's something called bounds change. So if you look, I'm making a lot of updates, and look at all this side effect logic right here. This is enormous. This is also hugely problematic because like these functions call other functions within the state, which can also call this function back. And so it's really hard to manage. So the workaround that I have for this is, so if you run into a similar pattern, please remember this. Make your state change first. And then when you need access to other elements of state, you want to do something like this pattern right here. So basically, you want the entire state object. You do a debounce time 1 and take 1. Let me explain why this is really critical for managing side effects. So debounce time 1 allows all your operations in the call stack to complete first. And let me give you an example of that. So on my map here, if I zoom in or zoom out, there's actually quite a few things happening at the same time. They're all happening synchronously. So the bounds are changing, so the square of the box, and also the zoom level is changing. So what the map does is it emits state changes to the parent component, and emits like 3 or 4 different things. All of those things get put into the store. And so now that poses a problem is because if you look on this one, this call right here needs to know the zoom level and the bounds level. So what if this function executes when between zoom and bounds update? What if bounds fires first and then this? And then what if zoom fires, then this, then bounds? So now we just opened ourselves up to a significant race condition for managing side effects. NGRX handles this very well with side effects. Akita, this is the pattern I've come up with. So one, you subscribe to the entire state object. The entire state object gives this function access to everything inside the store. What debounce time 1 does is it allows all your operations to complete before this fires. So in the case of zooms change, bounds change, all that kind of stuff, all those are coming up from the map. And this basically waits until everything's complete, so that way you're only getting the latest version of state. And then take one, obviously, because we only want a single operation. And so now we have our state object. And now we can do all our calculations. So if you look, you don't have to pay too much attention, but look, if zoom is set and I have bounds and the app is loaded, update mount, update the map data. If bounds is set, but zoom is not set, and this is a single property, update map blade. So basically now I have access to the entire state object and I can dispatch my side effects. This is okay, but if you notice, I now have multiple reducers firing. And so this is not a great, it works fine, okay. But when I have multiple reducers firing, I don't actually have one source of truth for state changes. And so it's okay. But when you're dealing with a lot of side effects, I think what I'm going to look at doing for future projects is only allow using Akita, but using a single reducer for making all state changes. Because if you'll notice, this is where things go wrong. This is where you can do a lot of naughty, bad things. And I'll just call out some of the things I had to discover the hard way. Making API calls. So you shouldn't actually do that in here. There's a couple of cases. So like this actually makes it. What I should have done differently is have something external to the store subscribe to an update property, and then use that to dispatch side effects. So dispatching side effects from inside your store, potentially problematic. I managed to get things straightened up, but I think in the future I would use a different pattern. Okay, so that is that. Let's see. So again, so this is an update statement, very simple. Each one corresponds one-to-one. You've got your perfect type safety. Akita is fairly good about preserving type safety. And then up at the top, if we want to see some examples of query selectors, let me just go ahead and find these. I've got a nice fat block. Just this simple. Really, it is this simple. So you name it, you call the query, and then you select a slice out of the store. A couple things to note, and these are big gotchas, is one, Akita deep freezes all state changes in the store. This is a really big thing to know. So this means that if you try to mutate anything downstream or anything inside the store, it's going to throw an error. And this is a good thing. So what the problem I had on this project is I was storing Azure Map classes inside the store. And what Azure Map does is mutate those classes. So it adds a bunch of properties, changes a bunch of things, and that's where bad things happen. So I had to change it, move those classes out, and have models would generate those classes. A couple other things to keep in mind. This is a behavior subject. So that means that late subscribers are always going to get whatever the latest version of the data is in the store. So Akita doesn't necessarily work for things like events where you don't want late subscribers to do that. The other thing that's important to keep in mind is the selectors are also behind distinct until changed. So like, let's say you keep throwing true at an Akita store. All your downstream subscribers are only going to see the first emission and go from there. So if you need exceptions to those edge cases, it's totally okay to have a separate property inside here that's sort of not managed by Akita, but it's still one source of truth and you're still following observable data flows and stuff like that. Okay, any questions on queries, stores, all that kind of fun stuff? Okay, so my last topic I wanted to cover, since we've got a few minutes left, is I want to show you guys how to roll your own. So state management is like a hobby of mine because it's such a hard subject and I don't feel like I've fully mastered every aspect of it. So let me show you. So on my Azure Maps store here, it's complex. We need to do our own state management. So the first question people are going to ask, like, why aren't you using Akita? Well, or NGRX or something like that. Well, one of the problems is that now adds, this is a dumb component and it's reusable. So this is essentially a library component. So the problem with using NGRX or Akita is I have now introduced a dependency that may or may not exist in the future. So if someone wants to use Azure Maps and I have an Akita dependency, they have to use it. So what happens in a year from now when we decide to go in a different direction and we discover a different project? We now have a breaking change. The other advantage is actually pretty simple to roll your own state management pattern. And this lets you kind of tinker and experiment and use sort of the best one for your use case. So with Azure Maps, I'm dealing with a large degree of side effects, and I'll show you that in a minute. So I have API calls completing at different times. I have user interactions completing at different times, and it's all coming down in this flow of data to the map. So how do we handle all that asynchronicity without introducing side effects or race conditions? And so the state management solution I selected, and I'll show you how we'll step through it. I think will make a lot of sense. And again, pros and cons. So I'm not saying Akita is better or NGRX better. It's about using the right tool for the toolbox. So the advantage of using your own state for lower order components, a lot of control, and you can kind of use as much or as little as you need. So let's go over a standard Flux pattern store that uses a reducer and with an observable data store wrapper. And I'll show you how easy it is, and it may be enough for your use case. Okay, so first thing you need is you need an object. So this is our POJO, plain old JavaScript object, right? And you notice I have it mapped to a particular type of state. You notice that's private because we don't want to expose this. And then what you need is a behavior subject that consumes the state. That's public. So if you notice, new behavior subject of this state, and it gets the initial state when it loads. I now have a store. It's just that simple. And so now when I add and remove key value pairs to this, and I'll show you what that looks like in a sec, this guy gets updated, this guy gets updated, and now my downstream observables, I can carve off slices of the state. So what's a state change look like? Very simple. So if you look, I just have one function that all my state changes flow through. Right here, I have action called state change. I have an action. Here's my state object that gets updated, and here's my reducer. As much of a pain in the butt a reducer is in terms of setting up, because you need to do actions and you need to have type guards to consume those actions to give you type safety. Reducers scale really well. The biggest problem with the Atom project is that kind of the approach that we did not scale well. And so while we try to get as many requirements up front so we can make the best design decisions, when you get requirements piecemeal over weeks, it makes it hard to have kind of future anticipate. And so Akita did not scale well. I mean, it's okay now, but the advantage to reducer is it scales. Like it scales further and further and further. Oh, go away, Dennis. There we go. Okay. Okay, so all state changes have to pass through this reducer. So when you call a function on this, the state change passes through the reducer, makes changes to the state property, and then it updates the observer. That simple. What's a reducer look like? It's really simple. It's just a pure function that takes the existing state and an action of how to change that state. And then the whole thing gets returned back to the store to update. Now, so one is this gives you a single source of truth for all state changes. And the other advantage, and I'm hoisting my own petard, here, you can't make side effects inside a reducer. So a lot of sort of bad habits that are really easy to creep up if you're just using this inside a service, you can't make here. The only purpose of this is to modify the state. And so what this does is it's real simple. So let me see if I can find a simpler example here. Okay, perfect. So resize the map. So basically, when the action comes through that says, hey, is this an action of resize, and the map exists, do something. That's it. And the nice thing is it's determinate and easily predictable. The other advantage, which I like a lot, is because all your actions are flowing through just this one reducer. If you console out what it's happening here, this lets you see the flow of logic through your reducer. So if we look here, let's go and look, see if I can make it a little bigger here. Make larger. Okay. Can I make this larger? I cannot. Oh, there we go. Just to see. Okay, so if you look, here is the reducer, sir. So here's the reducer. It says the reducer's firing. It tells you what action it fired and what payload. This makes it really, really, really easy to troubleshoot complex state change problems. Because with Akita, you have multiple functions sort of operating on the state. So what happens, this fires first or this fires first. You can put console statements on them, but then there's collision. With this, everybody's flowing through the single reducer. So I can say, okay, the first thing through, markers added, didn't add any. First thing through, layers were added, added 9 layers. Here's the layers that were added. Next thing through, we added some markers. Oh, empty. So we probably emptied out those markers. And so if you look at how much happens when the map loads. This is a substantial amount of state changes. And the advantage is because these are all coming asynchronously, it doesn't matter what order they come in, because that final state object that comes out of the reducer is always going to kind of be whatever that completed end state, because it'll take all it comes in and it'll complete end state. And then when we want to consume that, we would do something like this. So we would do public whatever goes this dot state pipe, and we would do, map states dot, oh, perfect. So here's all my data inside here. And then we would probably want to do a, distinct until change. Perfect. Look at that. So now this is essentially what Akita and NGRX and everything does in just a handful of lines of code. And the advantage is this is really easy to use. This is easy to modify. We don't have these complex packages that we need to install, all that kind of fun stuff. So, okay, so it's just an example of sort of how to roll your own store. And again, there's no right answer. Like there's pros and cons to both. And so hopefully, as you guys are looking at your next couple of apps, you can start thinking about architectural patterns for state management. So, okay, my mouth is dry and I've been talking for 50 minutes. So do we have any other questions or comments before I kind of end the session for today?
Thank you, Gerald, for putting that out there. Appreciate it.
Cool.
Yeah, thanks, man.
Okay. Any other questions or comments, ideas, patterns, all that kind of fun stuff? I can do follow-up. This is a long, complex topic, so if we need to do a follow-up session, happy to do so.
Can I ask like a specific question about the code that is in this project?
Do it.
So in the domain service,
Mm-hmm.
Can you open that up for me?
Domain service.
There's something regarding property downloads. If you can just Control F for that. Try just download, yeah.
Okay.
So I noticed this pattern as well, and I wasn't sure if this is something different. Like this is not really using, it's kind of using the store, but I'm not sure if it is.
No, yeah, fantastic question. Okay, so what you've just identified is a one-off. So one thing I want to stress again is there is no one size fits all. So, and this is why I went over the Flux pattern at the beginning, because you're going to find exceptions to this. Like entity stores don't work for every use case. Like in Brandon's case, you've probably seen the map data function inside here. It's too big for an entity call. So now we've identified, so what do we do with a one-off? So our Flux principle gives us one, is we need a single source of truth for whatever, right? Two, unidirectional data flow. So because this is data from the API, this is the correct location from this. Also, this download, so one, there's only one function to do downloads, and the response for this is not going to be shared. So this is actually a good example of an edge case to the usual like Akita or store. So this is just a single API call. Like there's no need to put this into a store, although there could be. But it's also like, this is also just a one-off. Like we don't have, like download is just an isolated thing. So do we need an entire store for managing downloads? Probably not. If we did, instead of putting this on like a UI store or domain store, it's probably easier just to use a behavior subject, like roll your own.
Yeah.
So those are sort of tools in your toolbox, but this is a great example of, again, like there's not a one size fits all. So when we think of Flux pattern, how do we get around that? So let's say in this particular case, Brandon, you said, right now, it's really just making an HTTP call and returning it to the subscriber. So there's no sharing of this. So that's probably fine for this use case, but let's say, a few weeks down the road, someone goes, oh, I need to have that data in two separate places. Well, how do we handle that now? Well, the way you handle that is we don't really need a dedicated entire Akita store, because the behavior subject is essentially a store, right? It's a single source of truth and we can put whatever in it. You just create a new behavior subject. And so when this guy returns, instead of returning it to the subscriber, you put the data in the store and return the store to the subscriber. Make sense?
Yeah, that makes sense.
Cool.
And then kind of following up on that, so this is kind of a mixed bag of things. As you can see, there's one part about downloading, but there's also another part about getting download statistics.
Yep.
So I kind of mixed it here, and that's where like I just started feeling like, what do I do?
Oh, I see. Perfect. You did exactly what I just suggested you. Are you just showing off?
No, because the thing is like I tried a few different ways, and I was like, this is all I could think of at that point after failing a few other times.
Yep.
Try to make it like more contextually like
related. This is actually solid, and I'll show you an example above in the above code that I did the exact same thing. But let me show you a gotcha, and this is really important. So let's say in this example I am downloading I'm dialing this, and you notice I'm returning the results of this HTTP call to the subscriber.
Mhm.
One of the potential problems with this is, what if I have two subscribers? They're both going to make HTTP calls, right? It's not a discrete, and event anymore. So it's possible this pattern is not wrong. Okay, it's just a tool in the toolbox. Just be aware when you're thinking state management, the ability to introduce sort of allow lower order components to do things that are wrong. So for instance, this has the potential to break unidirectional data flow. So right now it's fine. This is fine because we only have a single subscriber. This is only ever going to be used as the one-up. But let's say I now have two subscribers. If I have two subscribers and both subscribe at the same time, they're both going to fire off two API calls. And now I've sort of broken state management, right? And we don't want that. But because we are actually returning this to them, we sort of allowed that. So like, let's say we did need down the road to break this up into two stores. I would do exactly what you did right here. So have a behavior subject, and instead of returning the HTTP call, return the store instance.
Gotcha.
That makes sense?
Okay. Yeah.
So then the store is always the source of truth, right? And and lower order subscribers never get the HTTP call. So you basically have, what you've done in that case is you've prevented bad practices from being introduced. And that's not like a criticism of anyone. It's just, we're all working fast, or like, let's say I had to get in here and make a change because you're out or sick or something like that. I may not know the shape of your store. And so thinking, oh, hey, like, just in case that happens, I'm not going to allow Gerald to do something just because due a lack of knowledge or anything. So it's good to keep in mind stuff like that.
Gotcha. I do have one follow-up question, but I don't want to like take up the entire Q&A.
We got time. And let me show you another example of exactly called a different example of a store. So if you're looking here, I have an object called get map data. Now the amount of data for the map is enormous, and it comes back as one API call, and then it gets split out to all kinds of different sources where they get combined and then shredded and put back together again. So let me show you an example here. So here I have my get request, right? And I do a bunch of stuff. So I'm set the listing store, and you notice I'm returning the data here. But what I'm actually doing is I have a bunch of behavior subjects down here that are actually the source of truth for data for this store. And so that example that I showed you is like right here. So instead of actually returning the data instead goes to the store. That way we're still following that unidirectional data flow. So here's an example of another exception where maybe Akita isn't the right solution, but it's not hard to create our state management that sort of follows all the best practices.
Gotcha.
And a reset, of course, that's good. All right, next question.
Are there any like best practices of like when or how to reset a store?
Okay. No. So,
Okay.
it's going to be on a case-by-case basis. So for instance, okay, let me get it. So one thing to keep in mind is stores are potential memory leaks. Okay. So for instance, if you'll notice, if I start loading data into this store, these behavior subjects, they're going to hold, and like some of these API responses are really large. Let's just say 5 megabytes. So if I keep 5 megabytes inside each one of these guys, and then the user routes away, guess what? I now have a big fat memory leak where I'm holding on to this. And the answer is not to clear it or not clear it. The answer is be smart about it, because if you want to free up that memory usage for the rest of the app. But if you free it up, then they have to reload those API calls. So you're basically trading speed for memory. And there's no right answer to that. So in this case, I don't actually clear the store when they route away, just because the store the core is 90% of this app. I don't want them to have to reload API calls every time they come in and route away. So it's very, very fast. But if they go to like a my account section or something like that, maybe I do want to clear the stores to free up the memory. And in terms of reset, just to go full circle, there isn't a right answer. Sometimes you want to clear everything, like with an entity store, and sometimes you want to clear specific properties. So a solution to that, if I go back to my map service, let me find it just to see if I can find an example here. No, perfect, right here. So here's an example called updating parcel markers. You notice I have the ability to pass null to the store. And so what this lets me do is essentially null out that data in the store. And then if you get in the habit of doing this, your downstream subscribers can treat nulls as no data. And so basically I have data, do something with it, or null, either don't do something, clear something out. So it's a way to basically clear out properties on the store without having to like reset the entire thing. And it's on a case-by-case basis.
Cool.
Any other questions for me? Okay, cool. So I think we'll go ahead and wrap. Everyone, thank you for your time. I'm going to go ahead and post this session to the YouTube channel. And if you guys would like any follow-up sessions, you guys would like to learn anything new, if you guys would like to teach, these take a lot of time, and then they're very exhausting for me to do, and I would like to do them more. So if we can spread the load, that would be fantastic. So you have some cool thing. I know Brandon's been doing some cool stuff that I don't know how to do, like with asynchronous validators. So I might have to start nominating engineers to. It's like, I don't know how to do that. Brandon knows how to do that. I want to know how to do that. All right, my friend, show us how it's done. So yeah, that's the downside when you work with me on a project and you know something that I don't know, is I'm going to suck you dry. So. Okay, thanks everyone. Thanks for joining us. I'll have this up again. If there's anything you'd like to learn or anything you'd like to teach, please let me know. Thank you for your time, everyone.
Thank you.
Thanks, Farrell.